Back to the review for the college algebra final exam. We're on page 2 of the review that was provided. It's on solving systems of equations. And the instructions say find all solutions to the following systems of equations. And if you'll remember, we studied 3 different methods for solving systems. One was graphing, which is really not the best option because you have to estimate. So it's typically not the first choice that I would use. The second method we talked about was substitution. And then finally we talked about either the elimination, or it's sometimes called the addition method. And quite honestly, that's probably the one that I like the best, but we'll look at a variety of the examples as we go through these. So the first one is x plus 2y equals 3, and 3x plus 6y equals 2. Now, I could, since this first equation has the x with a coefficient of 1, we could use substitution. So I'll go ahead and do this particular problem by substitution. And so what I'm going to do is I'm going to solve this first equation for x. So I'm going to solve for x. And so if I do that, I would have x equals 3 minus 2y. I'm going to subtract 2y, I'll write it real small, from either side. And then I'm going to take that answer and I'm going to substitute it, hence the name, into the other equation wherever there is an x. So I would have 3 times, and in place of x, I'm going to put 3 minus 2y. And then we still have plus 6y equals 2. Now I have it all in terms of y, and I'm going to try to solve. So I have 3 times 3 is 9. 3 times minus 2y is minus 6y, plus 6y equals 2. If I simplify that, I have 9 minus 6y plus 6y goes to 0 equals 2. This is a false statement. And remember, when you get a false statement, that implies that there is no solution to the system. So our answer here is no solution. There's not a solution to this particular system, which is a valid option for solving a system of equations. Okay, the next one, x minus 2y equals 10, and 3x minus 4y equals 12. Again, we could do substitution here, but to illustrate it, I want to use the elimination method. And to get rid of it, I'm going to get rid of the x's by multiplying everything by negative 3. So that I have negative 3x plus 6y equals negative 30. And we're going to add that to the second equation, 3x minus 4y equals 12. Minus 3x plus 3x goes to 0. 6y minus 4y is 2y. Negative 30 plus 12 is negative 18. I'm going to divide both sides by 2. So y is negative 9. Once I know the value of y, I can backtrack and substitute into either one of the equations. So I'm going to use the top one. I would have x minus 2 times negative 9 equals 10. That's x plus 18 equals 10. And then I'm going to subtract 18 from either side. So I have x equals -8. So written as an ordered pair, my solution to the system would be -8, -9. And again, you may want to plug that in. Remember, if it's multiple choice, you can plug and chug and make sure that it's true in both equations. Okay, then here's a supplemental one. Here again, we could do it either way, either by substitution and solve for y in the top equation, or we can use the elimination method, which again I prefer. So I'm going to multiply the top equation by 2. And when I do that, I have 4x minus 2y equals 6. And I'm going to add that to the second one, 3x plus 2y equals 1. So that I have 7x minus 2y plus 2y goes to 0 equals 7. If I divide both sides by 7, I find that x equals 1. And then I take that value of 1 and plug it back into one of the given equations. It doesn't matter which one. I'm going to use the bottom one so that I would have 3 times 1 plus 2y equals 1. So I have 3 plus 2y equals 1. I'm going to subtract 3 from either side to isolate the y. So I have 2y equals -2. Then I'm going to divide both sides by 2. So y is -1. Again, written as an ordered pair, and I can confirm my answer by plugging it into both equations, ensuring that it's a true statement. Written as an ordered pair, 1, -1 would be my solution to the system. Okay, and that's the end of this video. We'll pick up with evaluating functions in the next one.